Hello, my name is Hamed Munkarisi. I am a PhD student in the software engineering group at the University of Sydney. Today I am going to talk about my project about detecting engagement and positive emotion using facial expression. We have done a study on writing activities in order to recognize the level of engagement of the writers during the writing sessions. As you know, writing is one of the most common activities among human-computer interaction activities. When you are writing, you are most likely to think about the topic of the writing. It's hard to think about something else. This provides a good environment for us to study the impact of the task on the user's mental states. To provide a more naturalistic environment, some noises were produced randomly during the session. You can see the impact of those noises in the user's behavior in this video as well. We used Microsoft Kinect camera to record color pictures, depth data, and audio as well. We are going to analyze video and depth to detect the level of engagement of the user and also his or her emotion. We ask the user to annotate the recording videos after each session. After analyzing their reports, we figure out that in most of the time they were engaged on writing a task, and only 25% of the time they were disengaged. So another interesting result was the relation between the positive emotion and engagement level. As we can see here, calm and relaxed were mostly reported in the engaged states, and bored was the most frequent reported emotion when users were disengaged. The differences between the value of valence and arousal in engaged and disengaged states were also statistically significant. As you can see here, the level of valence and arousal were higher when the user was engaged on task. Okay, this graph shows the average level of engagement and emotion across all users during the time. So they were almost 90% engaged at the beginning, and the level of engagement goes down as they were approached to the first deadline. After 30 minutes, they needed to submit their work at actually that time. So they took a break after that and received the feedback about their writing and started to revise their work. So the level of emotion did not change too much during this session. But we can see here in this graph can show the impact of the break and also the feedback on the level of engagement. After receiving the feedback, the level of engagement goes up again and actually start to goes down as they approach to the end of the session. Okay, two different methods were used for feature extraction in this study. In the first method, we used Kinect Face Tracker engine to extract the 6 animation units for facial features, 3 features for head rotations, and 3 other features which represent the position of the head in front of the camera. The second method is developed in our lab as well. First, we extracted the pixel values for 3 facial objects, eyes and mouth. Then we considered the time as a third axis and divided each video segment to 3 orthogonal planes. For each plane, we extracted local binary patterns and created the histogram. And finally, we concatenate all histograms to come up with a set of features for each video segment. Then we have done feature selection to find the best set of features which had a strong correlation with engagement or emotions. The result suggested that the mouth and head rotation were contributed more in engagement detection tasks compared to emotion detection. On the other hand, eyes and animation units played a major role in detecting valence and arousal. This slide shows the classification results for detecting engagement, valence, and arousal. Accuracy of 90% was achieved for engagement detection, 83% for valence, and 84% for arousal detection, which are pretty cool.